Today we are going to discuss about deleting a node from a binary search tree. Deleting a node is common with many data structures. The hardest operation in binary search trees is deleting a node. Once we find the node to be deleted, we need to consider several possibilities. There are four different possibilities: case 1, case 2, case 3, case 4. Case 1 is if the node to be deleted is a leaf node. If the node to be deleted is a leaf node. See first figure, it refers to case 1 where we wanted to delete a node with information 25. Node 25. The node 25 is a leaf node. We need to search for the node to be deleted. Once you search, if it is existing, a pointer is pointing to the node to be deleted. For example, position is pointing to 25, where 25 is leaf node. If we position a pointer to the node to be deleted, we can delete that particular node using free function, free position. Preposition, it deallocates the allocated memory of the node position so that the node will be deleted. If the node is deleted, automatically the remaining nodes becomes the binary search tree. No need to adjust the remaining nodes because there are no successive nodes of position, right? So then what is case 2? If the node to be deleted has one child, that is left is null and it may have right node. The node has only right subtree. It is not having left subtree. The node can be deleted after its parent adjusts a pointer to bypass the node. See here the second figure which refers to case 2. I wanted to delete a node with information 20. The node 20, we use it to search for node 20. Yes, position is pointing to 20, where position is pointing to a node we wanted to delete, which not having any left child, it is having only right child. Left is null, right is having a subtree. Now you wanted to delete 25. 20 can be deleted using free position, but if you free position of 20 or node 20, the remaining nodes has to be relinked with the parent node such that the remaining nodes has to form a binary search tree. The same fashion, case 3. If the node to be deleted has only one child, that is, it is if its right node is null and it may have left node. See case 3. Case 3. See the third figure. Suppose you wanted to delete a node with information 20, where we find a position of 20 using research function. Yes, position is pointing to 20. We can find that 20 is having only left subtree and right subtree is null, empty right subtree. See case 1, left subtree is null, it is having only right subtree. See case 3, it is having only left subtree, it is not having no right subtree. Now wanted to delete 20. You wanted to delete 20, you can free position is pointing to 20. If you delete position, the remaining nodes has to be readjusted or relinked to its parent node, right? We have to readjust the nodes. We'll show the how we can readjust the remaining nodes to the previous nodes or parent node. And case 4, the node to be deleted has both left and right subtrees. See here, suppose case 4, fourth figure, where you wanted to delete node 20, where you can search for 20 using tree search function. So if you apply tree search function, you can search for 20 and a pointer pointing to 20, position is pointing to 20. Now check whether 20 is having both left and right subtrees. Yes, 20 is having left subtree, 20 is having right subtree also. Now if you delete position, you have to readjust the remaining nodes, right? These nodes has to be readjusted and you can delete 20. In this way, we can delete a node. There are four different possibilities. First possibility is deleting a leaf node. Second possibility is deleting a node having only right child, not having any left child. Third possibility is deleting a node having only left child, not having any right child. Fourth possibility is deleting a node having both left and right subtrees. I will explain these four cases in detail one by one. Now, case 1, deleting a node having no children, that is deleting a leaf node. Assume that the node to be deleted is 25, that is target 25. So this is the binary search tree where we are going to search for 25 using tree search function, tree search, tree search 25. We are going to search for 25. If it is there, a pointer is pointing to 25. Assume that position is pointing to 25. It is there in the binary search tree. So we have pointed a pointer pointing to the node to be deleted. While pointing the node with a pointer, assume that we are pointing its parent node also with a pointer father, right? Successively move two pointers. One is pointing to parent, one is pointing to child. Now, while moving to position, always move one more pointer pointing to its parent. So position is pointing to 25 and father is pointing to its parent. Now, if you free position, right of father becomes unreferenced, but it should be made null, right? So wanted to remove position. See, position left is null, position right is null. Position is pointing to the node to be deleted, that is a leaf node. Leaf node means position left is null and position right is null. If it is, yes, if it is, what to be done? If father left is the position is left child or right child, it is right child. Is father left is position? No. Is father right is position? Yes. So else part. Father right is null. Father right is made null and free position. So 25 will be removed so that you will get this binary search tree. This is the binary search tree after deleting node 20, node 25. See here, 25 is deleted, right of 20 is null. Is the procedure how to delete a leaf node. Search for the leaf node. While searching for a leaf node, move one more pointer pointing to parent of every node. Now, by the time you find position of the target node, father is pointing to its parent node. Before removing position, father right is made null here. Yes. Then case 2. Deleting a node having no left children, that is, the node is deleted having only right subtree. Here, assume that we are going to delete a node with information 20. See the binary search tree. Here, I wanted to delete a node with information 20 using tree search function. Tree search function, we find position of 20. Yes, position is pointed to node to be deleted. And check, is position having only right subtree? Yes, it is having only right subtree. Is having left subtree? No, it is not having left subtree. If position left is null, if position left is null, yes, it is not having any left subtree, it is having only right subtree. If position left is null, what to be done? You have to delete position. Before deleting position, the right subtree has to be readjusted. See here how we readjust. T1 is position right, T1 is a pointer pointing to position right. Then position data is T1 data, position data already 20. It may be, it becomes 25. Then position left is T1 left, position left is T1 left, position right is T1 right. We are readjusting. Then free T1, T1 is removed so that See, you will get this binary search tree after deleting, after deleting 20. See, 20 is replaced with 25, then its left is 22, its right is 28, but here there is no node with information 20. 20 is deleted. Let me explain case 3. Deleting a node having no right children, that is, the node to be deleted having only left subtree. For example, target node to be deleted is 20. See the binary search tree. In the binary search tree, we wanted to delete a node with information 20. Use tree search function, tree search, use tree search function to search for node 20 if it is available in the binary tree. A pointer pointing to the node to be deleted or node we are searching. So 20 is available, a pointer position is pointing to 20. Check whether it is having only left subtree and not having any right subtree. Yes, it is having only left subtree. It is not having any right subtree. Right subtree is null. So right is null. It is having only left subtree. Now we need to delete 20. If you delete 20, the nodes that are there in the left subtree has to be readjusted or linked to its parent. So the left subtree has to be linked to its parent node. If position right is null, yes, position right is null. What happens? See, T1 is position left, T1 is pointing to position left. Then position data is T1 data, position data is already 20, it is replaced with 15. Position left is T1 left, position left is T1 left, position right is T1 right, position right is T1 right. Then free T1, T1 is removed. So that you will get this kind of binary search tree. This is the binary search tree after deleting, after deleting node 20. So after deleting node 20, we get this binary tree. Here there is no 20 node. Instead, the nodes that are there in the left subtree are readjusted. So 10 right is 15, 15 left is 12, and 15 right is 17. Again, all the remaining nodes forms a binary search tree. So in this way, we can delete a node where it is not having right subtree, having only left subtree. Now let me explain case 4. Deleting a node having both left and right subtrees. For example, delete node 20 from the binary search tree. So this is the binary search tree where we wanted to delete node 20. To delete node 20, first of all, we have to locate it. We have to find it. Use tree search function. Tree search 20. Call tree search function so that if it is available, a pointer is pointing to 20. Yes, 20 is available in the binary search tree. Position is pointing to 20. And the node 20 is having left subtree and it is having right subtree also. You can delete position, and before deleting, the nodes in the left subtree and right subtree has to be readjusted. The concept in here is that all the nodes of left subtree, link them to the leftmost leaf node of right subtree. Say there is a right subtree, leftmost leaf node is 22. 22 left is null, assign it to left of position so that it becomes a node which is to be deleted having only right subtree and not having left subtree like this. See here, we are converting this binary tree in this form. See here, 20 is the node to be deleted and the left subtree is linked to the leftmost leaf node of right subtree. So that it forms our case 3. It forms our case 3. Now you can delete this 20 by adjusting or relink all these nodes to the parent node. See, T1 is position right, T1 is position right. After finding the position, T1 is pointing to position right. Then use T2, T2 is also pointing to the same node. Then find the leftmost leaf node. Find the leftmost leaf node. Go to left while T2 left is not null. T2 left is not null. Yes, T2 is T left. T2 is pointing to T left. Then again check, is T2 left is not null? Yes, it is null. Once it is null means we reached the leftmost leaf node. Leftmost leaf node and left of leftmost leaf node is position left. Position left. T2 left is position left. So it becomes a binary search tree like this. Now position data is T data, T1 data. So T1 data is 25. It becomes, it is placed in position data. Then position left is T1 left. Position left is T1 left. Position right is T1 right. And free T1. T1 is removed so that you will get binary set tree in this fashion. So 25 is right of 10, its left is 22, its right is 28, and there is no 20. 20 is deleted. 20 is deleted. This is the binary search tree where you have deleted the target node. Target is 20. 20 is deleted. So once you wanted to delete a node with information 20 which is having both left and right subtrees, adjust first left subtree which is linked to the leftmost leaf node. So leftmost leaf node in the binary tree is 22. 22 left is linked to left of position C. Actually, this 15, 12, 17 is pointing here. So 22 is leftmost leaf node that is pointed to 15 so that it will get this kind of binary search tree. It forms our case 3. Case 3 is a node to be deleted is having only right subtree, not having any left subtree. Now we can delete a node with information 20 by adjusting all other nodes, all the nodes in right subtree by linking to its parent node. 20 parent is 10, 25, 22, 28, 15, 12, 17 all adjusted by linking it to its parent node of 20. Now we have got the binary set tree after deleting node 20. So in this way we can delete leaf node, we can delete a node having only left subtree, we can delete a node having only right subtree, or we can delete a node having both left and right subtrees by adjusting the remaining nodes. After deleting the node also, all the remaining nodes has to be connected together and it has to form a binary search tree. Thank you.